8.6 Scale factors in 3D objects. Now we're talking about things that have a length, a width, and a height. So remember when we were talking about things that had a length and a width, so 2 dimensions, we were talking about area, we looked at k squared. So now that we're talking about volume instead of k squared, we're going to be looking at k cubed. Okay? So this is what it says here. If 2 3D objects are similar and their dimensions are related by the same scale factor k, then the surface area of this similar object is equal to k squared, the surface area of the original object. Volume of similar object is equal to k cubed of the volume of the original object. So if you know the dimensions of a scale diagram or model for a 3D object as well as a scale factor, you can determine the surface area and volume without actually going through and determining all of its dimensions. So let's look at an example. First, I'm going to give you this. Here's some formulas for surface area and volume of some different objects. So rectangular prism, right triangle prism, cylinder, pyramid, right cone, and sphere. So I would take a second, I would pause this video, I would draw these out, or even take a screen capture and print this, because remember you can take one sheet into your exam and these formulas are going to help you. Let's look at an example. We have capacity. So a smaller tank has a capacity of 1,400 meters. The larger tank can hold 4,725 meters cubed. During the refining process, both tanks are filled with oil from a pumping station at the same rate. How many times longer will it take to fill the larger tank than the smaller tank? Okay, and then we're going to look at the radius. So, first of all, he said the ratio of the volume to the large to the volume of the small is ratio of large to small is 3.375. So that means it's going to take 3 times longer to fill this large tank than the small tank. Okay? Easy. Now we're going to talk about the radius. The volume of the large is equal to k cubed times the volume of the small. So then if I find that k value, I can know the relationship between the ratio the radius of the small and the radius of the big. So V large divided by V small, so we divided both sides there, is equal to k cubed. I already found this to be 3.375 is equal to k cubed. I cube root both sides and I see that it's 1.5. So the radius of the larger tank is going to be k times bigger, or in other words, 1.5 times bigger than the radius of the smaller one. So if I told you this radius was 300 meters, then I could divide by 1.5 and find the radius here. Okay? So it's simpler than actually having to find the dimensions. We're just finding k. And knowing that relationship of k cubed, or when we're talking about area, k squared, is really important.